So hopefully that kind of makes sense. This is shared ownership. The unique pointer was exclusive ownership. And the last thing we're going to talk about is this idea of a weak pointer. And I don't want to get too much into this. So I didn't leave any room for my drawings. I'm not going to draw much about them. I'm just going to acknowledge them. And if there's time, perhaps at the end of the week, we'll get into them a little bit more. But the kind of bigger focus here is going to be the unique pointer and the shared pointer, because for a lot of the application and the data structures that we've talked about to this point in the course, they should be sufficient for implementation. These weak pointers are more get involved when there's kind of cyclic relationships where a clear kind of sense of hierarchy isn't going to exist. So a standard library weak pointer is a smart pointer that acts like a shared pointer, but it doesn't participate in the shared owner count. It does not maintain a reference count. Well, it does. It has the same kind of information that the shared pointer does. It's just when we create a weak pointer from either a shared pointer or a pre-existing weak pointer, we're not actually incrementing that reference count that we saw here. So the object to which it points could have been destroyed. However, this pointer will know when it dangles. The reason why it will know is because it does have the access to see kind of, well, what is the reference count? Well, if the reference count is 0, I know that I'm a dangling pointer because shared pointer would have gone ahead and freed the resource. But you're going, but the control block, what you showed us here, was deallocated. Well, no, not necessarily. The shared pointer would probably check because within our control block, we also have a count telling us how many weak pointers are pointing to the object. So it might be something like the destruction process in shared pointer might be something like if reference count is equal to 0, deallocate the memory associated with, if the reference count is equal to 1, deallocate the memory associated with the dynamically allocated resource pointed to by, in this case, we named it resource. And then after we perform that deallocation, the next step would be, well, do we deallocate the control block? And you might go, well, if resource count is 0 and the weak pointer count is 0, go ahead and perform that deallocation. So I guess I could just draw on here and say we have reference count, but there's also a weak count. And throughout this entire process, that was 0 because we didn't show the creation of any weak pointers. So at this point, maybe you see a relationship between the shared pointer and weak pointer, because the shared pointer's control block is also storing information about not only how many shared pointers we have to the object as the reference count, but also a weak pointer count. And there's actually some other data associated with it too. So a standard library weak pointer is typically going to be created from a standard template library shared pointer that would be used as the initializer, the thing on the right-hand side. An initializer statement for a weak pointer would likely be a shared pointer, though not necessarily in all instances. And then the weird thing, which I don't want to get into much here, but I definitely will kind of maybe go down this rabbit hole if there's time. A weak pointer doesn't have a dereference operation. So we'll see this only makes the relationship with shared pointer closer. And there is some interaction of going not only from a weak or shared pointer creating up a weak pointer, but also from a weak pointer creating a shared pointer to do something. But again, the key thing here is that using these weak pointers, it's very easy to tell whether or not it is an actually dangling resource. A dangling pointer. The reason why we can't do that with our shared pointer is because, again, by design, when the reference count goes to 0, the object is destructed, right? Here, the resource that is owned is freed. In this case, we do have the ability to have a weak pointer dangle.